we have to solve the actual depth of the neutral axis. We have find out the actual depth, that is 173.58. Now we have find two things, actual depth and the critical depth. Now critical depth is 212 point something and actual depth is 173.58. Now actual depth is greater than or less than critical depth. Actual depth is less than critical depth. So this is which type of section? If actual depth is less than critical depth, it is under reinforced. XA is less than XC, it is a under reinforced section. What do you mean by under reinforced section? The depth is above this balance section. So this is known as under reinforced section. Now in case of under reinforced section, what we have said, this depth is less than this. So we have to connect it like this, not connect like this. So here the maximum stress taken by the concrete is less than the stress taken by the concrete. So we have to find out the value of the stress, maximum value of the stress that is coming to our concrete. As we know that maximum stress is taken by the concrete for M20 is 7 Newton per mm square. So this value should be less than that. So so we have to find out this. How we are going to find out? With the help of similar triangle. So this divided by this is equal to total divided by this. This is what we have to do. CA divided by XA. CA divided by XA is equal to TA by M divided by this or this. D minus XA. This is the value of what? This is XA. So D minus XA will be this. So this divided by this is equal to this divided by this. It is clear? In similar triangles, this is a similar triangle. So this distance divided by this is equal to this distance divided by this, what we have done. So CA by XA is equal to TA by M divided by D minus XA. Everything we have except then CA. So we will solve it. Sigma ST into XA, put the value of sigma ST we know 230, XA we know 173.58, M is 13, D is 750 and XA is 173.58. We will get the value of the stress what is coming to this concrete for under reinforced section. So this is the value of stress. As we have just thought that this value should be less than 7 Newton per mm square, it is actually we are finding this is less than 7 Newton per mm square. It is clear? This is the length. So according to that, we are going to find out the moment of resistance. What is moment of resistance? That is the formula, that is half multiplied by B into XA into CA multiplied by D minus XA by 3. This is what the lever arm. So directly we will, all the value we have, we will directly put it and we will find out the moment of resistance. Why we have divided by 10 to the power 6? Because all the dimensions are in mm, Newton mm. We have to find out the moment in kilonewton meter. That's why we have divided it 10 to the power 6. This is what we got the moment of resistance that is coming to our beam from the compression side. Now another case, there is no change in tension side. So whatever the formula for the tension side, we will directly calculate from the tension side. Directly put the value of TA multiplied by AST D minus XA. We don't have to find out the value of this stress. Directly we will find and we will get the same value whatever we are getting from the compression side. This is what directly we will find out with the help of this formula. But while we are finding out from the compression side, we have to find out the value that is change in the compressive stress in the concrete. This is how we are going to find out the moment of resistance in case of under reinforced section. This is what the first case has been clear. Now coming to it is clear. Now coming to the second case. That is what? 5 number of the steel of 25 dia. Again we have to find out the AST. Same thing what we have done. The XC is same because the section has not been changed. So XC is 212.65. Now coming to this again, actual depth of the axis. Now again put the value. Now here AST has been changed. So the value has been changed. So we will get from again by putting in the equation we will get. So XA will be 306.98 mm. Now here, what is the difference? We have got the actual depth greater than the critical depth. Now this is which type of section? This is over reinforced section. XA is greater than XC. It is a over reinforced section. Here the depth is below the balance section. So what will happen? Again we have to connect it. How we are going to connect it? Here the tensile strength has been changed. That's why we will directly put the formula for the moment of resistance from the compression side. We will directly find out the moment of resistance. But while we are going to solve for the tensile side, we have to again put the similar triangle TA by M divided by this equal to this divided by this. Again we have done this, CA by XA divided by TA by M divided by T minus X. So again we will find out the value of TA. Here CA is as it is sigma CBC, whatever the maximum value. Now again we have find out that value of TA as 131.34, that is less than the tensile strength what we have taken, that is 230. So again we will put it in the formula for moment of resistance for the tensile side. Tensile side it is sigma ST into AST D minus XA by 3. We will put the, here the sigma ST will be changed. It is not 230. It will be changed what we have got from here. So we will put it and we will find out the moment of resistance as 208.78 kilonewton per mm square. And again from the compression side we will directly put the formula half into B into XA into CA multiplied by D minus XA by 3. So we will directly find out. Here the value of the CA will be what? The maximum stress taken by 7. That is what again the value of the moment of resistance will be same from the compression side or from the tension side. This is what the case of under reinforced and over reinforced. Now this is what we have solved here. Now again the question has been asked, calculate the moment of resistance for the balance section also. So what should be the moment of resistance for the balance section? As we know that coming to the balance section, XA and XC are, we know that the actual depth and the critical depth are equal. So here we have to directly put the formula for moment of resistance from the compression side. We will get half B into XA into CA multiplied by D minus XA into D minus XA by 3. So this is what we have got. In the balance section, that is the moment of resistance is 151.62 kilonewton per meter square. Kilonewton meter. So this is what in under reinforced we have got the 96. In balance section we have got 151, and in over reinforced section we are getting 208 kilonewton meter. This is what the difference between the moment of resistance. Now again the question has been asked, this is what the moment of resistance. Now again we have to find out the area of steel. So again we will put the formula from the tensile side in case of balance section. Directly we will put bending moment is equal to sigma ST into AST D minus XA by 3. So we will get here, we will find out the AST. Now we will have moment of resistance. Moment of resistance for the balance section is this. We will put the value of this and we will get the AST by dividing this. The area of steel is 970.68 mm square. This is what the area of steel in the balance section. This is how we have solved the numerical. This is what all things we have got. But apart from this, suppose I am your examiner, I will not give you number unless until you will give this figure. This is the summary of the whatever you have done. This is the section, this is under reinforced, this is balance, and this is over reinforced. You have just mentioned the thing whatever you have solved. This is what under reinforced. Here the depth is 173, here the depth is 212, here the depth is 306. And the area of steel is here 603, here 970, here 2450. This is the change what we have. In over reinforced, the area of reinforcement is greater than that from the balance, and in balance it is also greater than the under reinforced. So this is what the relationship between the under reinforced, balance, and over reinforced. Now what is the difference between them? What is the compressive force that is coming to the under reinforced? That will be always less than the compressive force that is coming to your balance section, and that is coming to your over reinforced section. So C1 will be less than C2, C2 will be less than C3. And again the relation between the tensile force, as we know that in over reinforced beam the tension force is more, that's why the T1 is also less than T2 and T2 is less than T3. This is the relationship between compressive and the tensile force. Now coming to the lever arm. What is lever arm? Distance between the compressive and the tensile force. Again lever arm in the case of first, this value is greater than the balance section, and this is greater than the, lever arm in the under reinforced section is greater than the balance section, and balance section again greater than the over reinforced section. But the moment of resistance that we have got, moment of resistance should be less than the under reinforced section, and it is greater than in balance section, and again it is greater than in the case of over reinforced section. This is what and area of steel is also like this. Area of steel for the under reinforced section is less than the balance section, and it is also less than the over reinforced section. This is what the overall summary of the question that we have to do. This is what the analysis of the beam. Thank you.